All right, so this is quadratics number 14, special factoring. We've done factoring quite a few different ways. We're going to keep going at it a few more ways. There's like 22 lessons. There's a lot of lessons inside this quadratics unit. A lot of them sort of seem repetitive, and thank goodness, because I feel like it's a difficult topic. Okay, so hopefully the repetitiveness helps your brain start to wrap itself around this whole idea of quadratics. On the board are 4 examples that we're going to factor. What does factor mean? And do I have everybody's attention? Are you putting your screen down if you're doing something else? Let me try to get your attention if at all possible. What does factor mean? What's factor? What's the opposite of factor? All right, I can warm you up. We'll do some warm up. Ready? In math, give me an example of an operation. Dennis, I need you. Go do that. Please and thank you. What's the opposite of an operation? I mean, what is an operation in math? Multiplication? Check. That's one. Keep going. What's an operation in math? Division. See how your brains start warming up? More. What's another operation in math? Subtraction. And addition. Yeah, have we mentioned those 4? Those are the 4 fundamental, right? You start out in math, your very first years in elementary, right? Plus addition, subtraction, multiplication, division. What comes after multiplication and division? What have you learned since then? Root. And you picked the opposite. What's the opposite of root? The forward. Root's good. What's the opposite of root? So let's kind of list them. Here, we'll do this. Add / sub. Why did I put them on the same line? Because they're equal and opposite. Add is forward, subtraction is backward. In terms of order of operations, they're equal and opposite. Whichever one came first, I would do that first in order of operations. Does that make sense? Am I still in? Okay, thank you. So add sub. The next one, mult, div. All right? It's the next in the order of operations. It's the next in terms of importance, right? So you start with one, you move to the other, and we actually move backwards through this process, right? So we start easier, we get up to the higher level. The higher level happened first, and it moves backwards when we do order of operations. Okay, what else? You said root. I think what that would do is, where that goes is here in my list. The opposite of root is power. Say power. You might have learned, what's the other word for power that you might have learned? Exponent, yeah. Exponent is raising to a power, and root is taking it back down, going backwards, right? Forward and reverse. So now you have some variations on power and root, or actually mult and div, I might say. You have distributive property, distribute, right? Distribute and factor, okay? And these are really variations of multiply and divide. And so we're going to do factor here. We're going to do a division process is where we're getting at, right? Just to warm you up a little bit. Okay, does that help to get your brain going? And these are all called operations. Weird words. I don't know what to say about it. Somebody needs to go through and rename everything in math. Well, not everything. Some things are good. I like some names. But some names are kind of weird. Okay, so operations. So we're going to factor in this case, special factoring. We're dealing with quadratics. Tell me what's the most fundamental quadratic you know? What makes a quadratic? 4 is always your short answer. Longer answer. What did you say? Foil. So 4/foil. What else? How do you explain that? What am I describing there? What's being explained with that? 4 what? Steps. Multiplication. Okay, I appreciate it. Between all of you, it's coming together. 4 multiplication steps. You with me? So the opposite of this, opposite of multiplying that out, you're reversing 4 multiplication steps, right? And actually, when you multiply, there's an addition step in there. Go ahead. Yeah, factoring is the opposite of FOIL in this case. Thank you. Do you see how your brains warm up? Does that make sense? And when you guys hear that, does your brain go, yeah, okay, at least I'm on track now, right? It's so interesting. You can just see the cold brain versus the warmer brain. It changes everything, right? So the opposite of this is factoring. Tell me about what gets multiplied together to produce that quadratic. Do you remember that? What is it? Something times another? Yes. What times another? Did you say it? I can't.
11 times
11 times 11. Oh, you're already going for some solution here. Do you remember the setup of what we multiply when we produce a quadratic for these? Parentheses? What's it called? What are the parentheses called? What's in the parentheses? Come on, push your brain. Pull it out of there. Do you remember my 4-year-old son? There's a little man in your brain, and man, there's a little, I don't know if he said man. Maybe he did. And it runs back into the library stacks and pulls out the right answer and holds it up to you. There's an X. Good. So something that looks like this. Let's warm up on that. You've got 2 parentheses and you have something like this and this, right? Let's just make up something, right? There's 2 items in each, so what do you call each?
Variable.
That's a variable, yes. It's a variable X. There's 2 items in each, so what do you call them? Good, that's where I was headed. Everybody go. Binomial, right? It's 2 binomials multiplied times each other. And the 2 binomials make 2 each. That's how you get the 4 FOIL steps, right? Does this all start to sound familiar? Okay, I hope you're doing enough of these that you're trying to get these going, right? So let's talk about these special ones. Special factoring. Why is it special factoring? Let's go for the solution. If I've got 2 parentheses like this, and we're going to do it for all 4, so I want your brain to think about all 4 at the same time. We're going to factor them. Tell me what I can do right here. Louder. Say it one more time. It's not that it's wrong. I can't. I literally can't.
Put x minus 11 in the first one, and then is it x plus 11?
What do you think? How are we going to check it? How do we know? Just FOIL it, right? Are you with me? We're just, at this point, we're just guessing and checking, but you can go straight to this. Why did you pick 11s? Tell us your reasoning. I mean, I don't know what's, you're kind of laughing about it like you're nervous about your thought process, but I don't see that's a great thought process. That's where you're headed, right? That's perfectly right. Okay, why did you pick a negative and a positive? Because it's negative. All these are rational thought processes. You're totally on the right track if your brain's thinking this, okay? This is totally logical thinking. All right, so don't be embarrassed by that one bit. Anyway, I want to encourage you. You're doing a great job with that, right? Don't pull away. Move forward through that thinking, and encourage others to do so too, right? Now, when these multiply, you get the x squared, right? Why is there no? Well, let's do the FOIL. The FOIL will be first, so x squared, then outside, right? O. So 11x, and it's a plus 11x, but look at the inside. Negative 11 times x is negative 11x. What's happening here? Then this is negative times positive is negative 11 is 121. Fair enough? And remember the combined like terms, the CLT, right? It cancels. This is one of those special cases. And so this is really quite brilliant to be able to go this direction. At some point, you're building up some history with this topic. Okay, your brain is gaining some traction with this whole idea, especially if you're able to think through this. Does this make sense when you see it at least? Kind of? Go like this. And remember, you can always say, I don't know yet, right? I don't know yet is fine. And pass is always fine too, you guys. Okay, so at some point, you've got to engage it to make it your own, right? So these cancel, because when you now add a negative 11x and a positive 11x, they're gone. And what's left? X squared minus 121. So we proved it. This is the true factoring of that. All right, are you ready to go next? Don't do this one, Vera. You wait. Andrea, can you do this one? I'm going to write it. It's not right, but I want to go with it because here's what you do. Pick your best answer and do it, and then check it, and then make your adjustment, right? This is the way life is. Life is iterative. You go through a cycle, right? And it's better to pick, this is going to sound crazy, it's better to pick a wrong answer and move forward than it is to wait for the right answer. Are you with me? We humans work this way. We pick a wrong answer, we move forward, and then we test it. Okay, so you said this. X times x is x squared. X times negative 11x is negative 11x. Negative 11 times x is negative 11x. Negative times negative is positive. 11 times 11 is 121. When I CLT, what does this come out to be? What's my problem here? And how do I fix it?
Oh, it's negative.
Hang on 1 second. Yes. Hang on. Yes. What do you think? What happened? First of all, what's different? What's my only thing different in this to this?
The 22 is your positive, it's a negative.
What do you got to change to fix it?
You get a positive.
Yep. Which one?
The first one.
What?
The first one.
But wait a minute. Just the first one? Because now, if I do this, I get x squared. I'll get a positive 11x and a negative 11x, and it'll disappear in here, and this will be gone.
The second one.
Now I'll get an x squared, I'll get a positive 11x and a positive 11x and a positive 121, so this will be this. Does it help you? Do you see the process of take a shot at it, write it down, multiply it out? Now I can go back and figure out what to do to fix it, right? So now this is right. What's the beauty of this thing? This is not totally done yet. We can get more elegant, as we say in math. There's a more elegant answer to this. What is it? What's the more elegant answer? This is right. This is an answer. You can do one more step. Is this the same as that? Yeah. What can I say about this if this is the same as that?
X plus 121.
What?
X plus 121.
No. This. Here's where I'm headed. I'm sorry to say no so abruptly. Okay. I'm headed a different direction. Here's what it looks like. Is that right? Isn't that cool? Because they're the same, you can just write one of them and put the power 2 on it. There's 2 of those now, right? Why couldn't you do this here? They're not the same, and your brain has to key in on all the little details. That's part of the advantage of math. It forces your brain to think about, it's a subject that tests your brain on details, right? You need these subjects for exercise alone, just to exercise your brain. Maybe you're never going to go into a math subject, but you can use the subject to make your brain stronger so that when you find what you love, your brain is now tuned toward details and other aspects, right? Okay, can you do this one? That's who's my next in line? Who wants to try next? Lizetta, are you in on this? Are you watching what's going on? You want to try this one? What is it?
Would it be x plus 6 and x minus 6?
So let's try it. X times x is x squared. Outside, minus 6x. Inside, plus 6x. Last, negative times positive is negative. 6 times 6 is 36. What happens when we CLT? Gone, gone. Right? Pretty cool, right? Can I do this with this? Or I mean, can I do this with this? No. Why?
Because they're not the same.
They're not the same. Reasonable? Do you see the patterns? Our brains love patterns, right? Do you see the patterns? All right, who's my next victim? Anybody want to try? Volunteer for me. Who's next? Anybody close enough where you're like, I know enough, I can do this? Susanna, have you been watching? You can always give me a pass, and you can give me a not, I don't know yet. You can always do that. Got it. Thank you. Dennis, are you with me? Have you been watching?
Is it -6 and -6?
Tell me what to write.
X -6
X times x is x squared. Outside is minus 6x. Inside is minus 6x. Last would be negative times negative is positive, and 6 times 6 is 36. When I CLT, that was a terrible bracket, negative 12x, x squared minus 12x plus 36. That looks just like this one. Check. Dennis, can you make it more elegant? Close. But not quite. Look back at this one. Use this as an example.
-6 and 2.
What do you call this? You're saying it.
Power of 2.
Thank you, thank you, thank you. Yeah, my job is to try to push you to do all the words, right? To say, I know it's in your brain, but to spit it out. You okay with this? Okay, these are factoring special products. These are some of the fun ones. Why are they fun? Because when you see this kind of thing, right, it's more challenging for students. It's harder. I don't see everything all at once. My brain has to know more. This is more fun because this whole canceling of the interior term when you now switch to the addition and subtraction. And this is quadratics number 14. You can practice the special factoring.